In this video we're going to work through our 4 multiplication types. So we'll start off with a normal times a normal giving a normal answer. So if you head first of all into the spreadsheet. Now the spreadsheet's in the resources section, so you can go and open it up, and if you click on floating point multiplier, now for the normal number we'll use the numbers that we've had used previously. So we're going to have minus 0.7 and we'll multiply that by 492.75. So these are our answers here. So if you take a note of these multiplications, the two values in hex and also the answer in hex as well, and we'll go and we'll put those values into the multiplication tool in Logisim. So if you head in and open up Logisim and click on the top level here, which is the test, and you should have this screen here. So let's put our values in. Now make sure that you've got the little finger ticked, otherwise it won't run through the simulation. So for our x value we're going to have a BF and 1, 2, 3, 4, 5, 6 threes, and for our y value we're going to have a 4, 3F, 6, 6, and we're going to have 3 zeros. And you can see that the answer here is that C3AC7666, which if you check back in the spreadsheet you'll see that that is indeed the correct answer. So that's good. Now what we want to do is have a look through and see what's happening within the actual multiplication unit here. Now the first thing we want to do is to understand what the inputs are and what the outputs are. So we're going to do this in this little block called type. So if I head in here, you can see that the top bit portion here tells us whether the input is going to be a normal or a subnormal. So we simply have our OR gates, and these will OR together the exponent values, and you can see here if it's a 1 it's a normal number, and this xn this is a normal number, and the y is also a normal number. So we've made the right choice, it is a normal times a normal. Now the output is determined by this section here. So if it's within these two ranges, then it would be a subnormal number. If it's not within those two ranges, then we assume it's going to be a normal number for the moment. So that means that the output here is going to be a 0, which is a normal number. So this section is working right. It's telling us that we've got a normal times a normal, giving us a normal result. So that means that we can use the values here that tell us whether the input is going to be normal or not in the exponent area here. So for example, we can get into our little biasing section here, and because we know the input for x is a normal number, it's going to choose the bias via this route here, which is going to be the biased exponent minus the value over 127. So the route in through is in this direction here. Now this route here, we would use this route if the number had been a subnormal number, but it isn't. Okay, so we do the same for the second value here for our EY. We know that it's a normal number, so that's going to choose this route here to get the EY minus the value of B, which is our 127. And then we're going to add both of them together, and then we're going to create the EX plus EY plus B section here, and we're also going to have the EX plus EY plus B plus 1 coming down this route here. And then we're going to have to choose between these two. Now the choice between these two is made via this OR gate, and it's either going to be a high value if the last bit of the 48-bit multiplication is a high value, and again you can see here in this case it is, and you can go into the spreadsheet which we use for our multiplication and you can check the 48th bit of that multiplication. You'll see it's a value of 1. So that's going to choose this path here. So it means that the sum's going to come down through here and down through this path here, and then it's going to choose this one here, and then when it gets down to this point here, we have to decide whether the output is going to be a normal or a subnormal. In this case here we know that the output is going to be a normal because we did this up here. So it means that there's a value of 0 here, so we're going to pass the value down through this path here into the output. So we get our final output here for our exponent, and of course our sign bit's quite straightforward. We get our exclusive OR for our sign, so that does our sign bit. So the next thing we want to do is look and see what's going to happen at our mantissa section. So if we head in here, we can see here that the value for the xn is a value of 1, that is it's a normal input. So if it's a normal input, it means that we're going to bit extend this. So we bit extend this by a value of 1 in this case, because this is a normal number. So the path in this line here is going to be through here. We'll get the bit extension through here. It's then going to come down through this route here, out through the multiplexer, and this chooses this value for the multiplexer, and it heads out here. Now, if that wasn't the case and it chose the different route, then it would come down through this route here, and we would get this if we were doing the pre-normalization of a subnormal number, and we would be getting the leading zero count as well, and the route would have been down through this route and then out, but it isn't because we've got a normal number. So it's a simple route down through, out here and out there, and it just puts a value of 1 and a 24th bit, and you can see that happening here. And of course we get exactly the same for the y value, and we get a 1 appended at the front here at the y value. We then head down into the multiplier, and the multiplier is exactly the same, there's no change in that. And then we head into the shifter, and as I say, in the shifter, this is where all of the choices are made for the mantissa. So we've got 3 different things we can do with the mantissa. We can shift it by 1 to the left, or we can shift it by 0, that is, we just leave it, or we can shift it by this value here. Now in this instance we know that we're going to have a normal output, and we're going to have a value of 1 in the most significant bit of the multiplication, so we know we're going to have to shift the mantissa left by 1 in order to normalize it properly. So in order to do that, it's going to come through this path here. So it'll come through this path here, and we'll shift this by a value of 1, and we'll drop off the most significant bit, and this is going to give us the correct mantissa value, which is this one here, and that's chosen by the 48th bit. So let's head down and we'll look at the rest of it. So after we've covered this part here, we're going to have the 2 outputs coming out of here, and we know that we're going to choose the normal one because we've got 2 normal inputs. So the subnormal you see is low, so it's going to choose the correct value. It's going to choose this one here rather than this one here, which would have been the subnormal one. So finally we're going to head out down through here, and we've got the incrementer section, and this would be determined by the rounding section here. So the rounding section would come out, we'd have worked through the rounding, and we'll either have a high or a low bit, and if we had a high bit then it would round the value that we have here, but in this case here you can see that we've actually got a low output, so there isn't any incrementation here, so there's no addition of an extra 1 there due to rounding, and there's no carry bit coming out through there either. So it means there's no path coming through here to the OR gate. And finally we get our final output down to the mantissa. So that's the route, and we're going to talk through the same route for the next 3 examples as well. So go ahead and open up the multiplier tool again, and we're going to put in another couple of values. So we're going to put the value 10,000, and we're going to multiply that by 1e to the minus 40. And you can see here we're going to have a normal times a subnormal giving a normal result, and these are the values that we want to put into the multiplier and Logisim, and this is the output we expect to get. So let's go and we'll put these values in now. So let's go and we'll put our values in now. So we're going to have our 461C4123, and we're going to multiply that with 000116 I'll put that in again. We're going to have 000 116 C2, and you can see that we're going to have this answer here, 3AA23E8, and that's the correct answer again, which is a bit of a relief, isn't it? So let's go in and have a look and see how this does the multiplication. So again, we start off in here, and we can see here that we're going to have a normal times a subnormal. So the subnormal is the y value, and we can see we're going to have a normal output. So we've got the right values here. So we head into the multiplier again, and when we come in here for the x value here, again it's going to choose the normal root, which is this root here, and it will give us our output for our unbiased output. And then when you come into the EY root, so the EY, the Y one is going to be the subnormal, so it's going to have a 0 on this, so it's actually going to come through this root here. So it's going to have worked through the normalization of the input, and we get this worked out the pre-leading 0 count in order to go through whenever it's going through that normalization. And so the output is actually coming from this point here. So we're going to get, in this case, minus 126 minus the pre-leading 0 count for our unbiased exponent for the y value. And then we're going to do the addition here. We're going to work through the summation here as well, and we come out at the bottom here, and we know that the answer is still going to be a normal answer, so it's still going to choose the value of that's going to come down this route here, and it's not going to give a subnormal output, so it's going to come down this route here and down to the exponent. And you can see here in this instance the 48th bit, and this one obviously it must be a 0, so it's not doing the plus 1, so it's going to come down here, down here, down here, and out through here. So if you check in the mantissa section, you can see here that the mantissa section, again in this case here, is going to be a normal input for the value for our x, so it chooses this path here, so it comes along, down through here, and out through this path here. And if we check the same thing for the y value, you can see the y value in this case is a value of 0, so it doesn't go through that path there. This one goes through the subnormal path, so the subnormal path is going to come through here, it's going to come down through here. So the leading 0 count gets done here, and this will put an output here for the leading 0 count for the y value. And also that leading 0 count is going to be used in order to do the pre-normalization of that subnormal number. So it's going to shift that number to the left by this number of the number of decimal places dependent on the leading 0 count. And that's going to give us the output here, which is going to be our pre-normalized subnormal number. So the route is going to be down through here, along there, up through here, and then out. And then there's no difference here in the multiplication. If you get into the shifter, now we know that we're still going to get a normal output, and in this instance here, so it's either going to be a 1 or a 0 coming out here. In this instance here, the 48th bit is a 0, so we're not shifting it to the left, there's no normalization required. So it means that we're going to work through this route here, and this route here is going to give us the correct value for the mantissa when there's no change. So we head in through here, out through here, and through the mux and to the output. So the path now is there, down through here, and then out through here. And finally, whenever we head out, you'll see that the output here still got to get chosen, but we know it's going to be a normal output. So the subnormal value is a 0, so it chooses this normal output. So we're saying it's choosing this one here as opposed to this one here. And finally, we have our output coming down through here, and if there was any rounding, it would be added on at this increment section, but again, there's not any rounding in this section, so it's just going to head straight out here, and we're going to have our mantissa out to this point. So that's us done 2. Let's move on to the third one now. So you can head in and open up the tool again, And if we go into the multiply section, now we're going to put in the number 10 and the number 1e to the minus 40. So you can see here we've got a normal times a subnormal, and we've now got a subnormal result. So again, we can take note of these numbers and then we'll go and we'll put them into the multiplier in Logisim. So we'll make sure we've got our little finger clicked here to run through the simulation. We click on here and we'll put in the number 412, and there's 1, 2, 3, 4, 5 zeros, and the second number is 000 116C2, and you can see that the answer is 000 AE394, which again is the correct answer, which is good. Now if we head back down into the section here, so we know that we're first starting off in this type position here, and we can see here that we're going to have the x value is going to be a normal, the y value is going to be a subnormal, and we can see here now the output is going to be a value of 1, which is a subnormal output, so we've got the right values here. So we head in and we can look at our x value. So our x value here, again, it's the normal value, so it's going to choose this route here to get the correct bias. And then the y value here, you can see it's a subnormal value, so it's going to choose this route here in order to get the correct bias, which is going to be our minus 126 minus the pre-leading 0 count. And it's going to go through the usual route here for the summations. And at the bottom here you can see that there is no 48th bit. The 48th bit is low, so, and there's no incrementation here either, so through the rounding. So it means that there's no output here, so we don't go through the +1 route, we just go to the EX plus EY plus B route. And then whenever we get down to the bottom here, you can see that the actual value that we're going to use isn't this value here that we've worked out through this tree. The actual value that we're going to use is just going to be the value 0 because it's a subnormal number. So this little tunnel here, this overwrites whatever we've done down here, and we just get the value of 0, 0 coming out here. But the reason for still working through this is that we're able to take the values here and we're able to use them at the mantissa section here in order to get the right shift. So we can see we're taking the output here and we're using this in order to get the right shift at the mantissa. So let's have a wee look through the mantissa section. So we're going to have our normal number coming in here, so we've just got a normal bit extension, so it comes along here, down through here and out through this point here. Now if we begin and we head in and we'll have a look at the Y section here. Now the Y section is different because we're going to have a subnormal number here. So instead of going through this route here, it's going to come through, down through here. We're going to work out the leading 0 count, so we get the leading 0 count coming out here, and then we're going to do the pre-normalization. So we're going to change the subnormal number into a normal number, and we're going to shift it out through here. So you can see that this one here has now been shifted, this one has now been shifted up to the most significant bit up here, and all the rest of the ones have all shuffled up as well. So we've got the correct value here. And then we're going to do the multiplication, and finally we're going to go through and we're going to look at the shifter section here. So in this case here, again, we're going to create this output here, but ultimately we're not going to use this because we know that it's going to be a subnormal output. So in effect we're going to be using this number here, which has been created through this route. Okay, so this is the route that we used in order to shift the value for the mantissa. And again, we've shifted the value of the mantissa by that bias value. So in effect we've shifted it right by this value here, and we've just put in all the zeros in at the front. So we're actually going to, in the next screen, we're going to choose this one here, which is the subnormal one as opposed to the normal output. So let's have a look and see, and that choice is made here, and you can see that it chooses the subnormal output from this, and it goes down through the mux. And again, there's no rounding in here, so there's no addition, and this goes going straight out through to the output and gives us our correct answer. So that's the third one done. Let's move on to the last one. So open up the multiplication tool again, and we'll put in the two values. Let's say 1e to the minus 19 and 1e to the minus 19. So we've got a normal times a normal now giving us a subnormal result. So again, we can take a note of these here, and then we'll go and we'll put them into the multiplication tool in Logisim. So we'll put in the values 1f, ec, 1e, 4a, and again the same value again, and this for the y value 1f, ec, 1e, 4a, and you can see we get this output here, and this again is the correct output. So let's go in and we'll have a look, and again we start off at the type, and we can see here for the type that we've got a subnormal number coming in for, we've got a normal number coming in for our x value, we've got a normal number coming in for our y value, but we've got a subnormal output, and we can use those on the tree here. Now again, we work down through and we have our value here for our x, which is a normal value, which comes through here, and we've got a value for our y, which is a normal value again, and it comes through this route here. And then we do the additions here, but whenever we get to the bottom here, you'll notice that, well, in this instance here, we've got a 48th bit as a high bit, and you can check that on the multiplication tool in the Excel VBA. So it's going to choose this path here, but it doesn't really matter when it gets down to the bottom because it's a subnormal output. So a subnormal output, it just forces the outputs all to 0. So we get all zeros for the output. We get our sign bit here, and the value here for our bias, which we've worked out, goes into the shifting section. So again, if we head up in here to the mantissa section, we're going to have a normal value here, so it just passes through this route here, down through and out, and the very same for the y value, passes along this route, down through here, and then out through there, and the final output here down into the shifter. You can see that in the shifter we're going to have a subnormal output, so it means that we're going to, instead of going through this path and choosing this one or this one and choosing that, we're going to be working through the subnormal output path. So this is the subnormal output path, so it means that the mantissa is going to be shifted by this amount here, and we're going to generate that from the bias. So in effect what's going to happen here is that the mantissa is going to shift to the right by this bias value, and we're going to choose this output here, and you'll get that choice on the next level up. So again, we come down through here and we're choosing the subnormal output, and that's coming down through here, and in this case here there's no rounding either, and it's just going to head straight out to the mantissa section. So that's us covered all 4 of them. It's quite a long video again, but I suggest what you could do is you could put in values for yourself and you can mess about with it. Once you actually do it 2 or 3 times and you look through the path, it all becomes quite apparent what's happening and why it's happening. So thank you for listening. I'll get you on the next video. Goodbye.